Is that something that is an important biosynthetic process for the cell? No, it's not. It's just something that it's dumping. You're just dumping these. The muscle's dumping them under oxygen debt, so it can just keep generating energy. But the cell is not intent on biosynthesizing lactate. It's intent on, glucose, you're going to make ATP, you're going to make, you can use it for glycerol scaffolds, you can use it for amino acid biosynthesis, you can use it for a lot, but making lactate is not a biosynthetic product. So, okay, so that's pyruvate, acetyl-CoA. We know we can fatty acid biosynthesis or fatty acids. You can get to acetyl-CoA, and with the other way, you get to ketone bodies and the precursors for cholesterol. So voila, I think that's good. So key junctions, and then and is this where I trotted in these slides about oxaloacetate? Yeah. No, they're not here in your notes. Remember, and that, that was just because Mei Lin, taught me something. So, yeah. And plus, what that also brought up is there's another way to get NADPH, because all of that was involved in shuttling acetyl-CoA out of the mitochondrial matrix as citrate, and then it breaks down, and then you get you've got your oxaloacetate, and then from that you can remove a carbon and remove electrons as NADPH. So I think that's important to know, because it was in the slide when we first talked about those shuttles, and it was way too complicated, and I didn't really pay enough attention to it. So I just wanted to bring that up. Okay, so
you repeat what you just said was really important?
It wasn't.
The production.
Yeah. It's just good to know. It's not all coming from pentose phosphate pathway. Yeah. Okay, where are we?
Metabolic profiles of organs.
Yes. Okay, so Cori cycle, we've seen that. I made those notes about the brain using 60% of our glucose. I thought that was interesting. It can never switch entirely to ketone bodies. I think about only half of it can be ketone bodies. What else was there? The kidney. Half of gluconeogenesis. Isn't that right? Isn't that on that slide? Mm-hmm. That's kind of surprising. That doesn't really, we just hear about liver. The kidney. So kidney failure, it's you really got problems. So kidney, and then I guess we look at this the role. So liver with muscle, liver with fat. So liver with muscle, we've seen this Cori cycle again and again. I think this slide, it just trots in what we learned about alanine as a carrier of amino groups, right? I think there's an arrow for that we hadn't seen before when we looked at the Cori cycle and carbohydrate metabolism. Then that leaves us with fat. So always a great topic. So I think this is pretty astounding. I try to drive home this point in the lecture, but okay, anybody want to take a stab at it? What was the take-home message about fat? This fat cell. What's the take-home message?
It's a cycle. It's turning it over.
They don't go away.
It's turning it over, and so what are the two outcomes? Because it's more than it's just turning it over.
It's you either use it for energy
you resynthesize the fat. Okay? So I think that's strange. So, you know, as we're sitting here, this fat that, you know, I feel like it's just never going to go away because I'm not 19 and surfing 6 hours a day anymore. So there was a day, you know. So it just doesn't go away. But actually it's going away. It has plenty of opportunity to go away. So what am I doing that's preventing it from going away? I'm snacking all day in my office. It's healthy snacks, but I'm snacking all day. And so I've got a constant blood glucose level, pretty constant. And as a result then, does the fat escape, or it just is reformed? It's just this cycle. So I think that's really strange. So, you know, so what we learned, our liver has enough glycogen to provide glucose for the body for 4 or 5 hours, so that's just about a meal duration. So, yeah, so at that point, then that's when you're mobilizing this triglyceride, which is fatty acid, which is then going to supply, what does it say, peripheral tissues? And glycerol. And then what happens to the glycerol? It goes to the liver, and then what does the liver do with it? It makes more of that glucose for the brain. So fat is actually helping your brain with glucose via the glycerol from the breakdown of the triglyceride. So I think that's pretty remarkable. Okay.